What is free surface effect and what is its impact on the ship's stability when the ship is listed? If a tank is completely filled with the liquid cannot move and acts as a static weight. So, the center of gravity of the ship remains unchanged. The graphic shows the listed ship when the tank is filled with liquid. Assume that the ship floats at the same draft with the same kg and with the tank partially filled. Now, if the ship lists, the liquid flows to the lower side causing G of the liquid to shift to G1. This results in the center of gravity of the ship G moving to G1. This effect is called a free surface effect. As a result, the vessel suffers an apparent loss of Gm which is equal to GGV, and hence the metacentric height is GVM. Gz, the righting lever, is also reduced by an amount which is equal to GG1. This virtual loss of Gm can be calculated. It is called a free surface correction or FSC. In order to indicate whether FSC has been applied or not, the Gm before subtracting FSC is called solid Gm. The Gm attained after applying FSC is called a fluid Gm. In all stability calculations, you will use fluid Gm. If the area of the free surface is constant, the weight of liquid in the tank does not affect the FSC. Within the ship, the position of the tank does not affect the FSC. When a tank is either empty or full, FSC is 0. To reduce the total FSC for the ship, the number of slack tanks must be kept to a minimum since the FSC of each slack tank contributes to the total FSC for the ship. By fitting longitudinal divisions in the tank equally spaced, the FSC can be reduced to 1 by n square times the undivided value. N is the number of spaces. Example, 3 spaces are produced by 2 longitudinal divisions and the FSC reduces to 1 by 9th value of undivided tank. FSC will make the situation worse before the bottom weight increases to a sufficient level to bring G down if time is taken to decide and start filling a DB tank to improve stability. The smallest tank on the lower side should be filled first if the ship is at an angle of LOL.